In this question, a screen and an object is placed at capital D distance apart. The image of the object on the screen is formed by a convex lens placed between them at two different locations, separated by a distance small d centimeters. Find focal length of the lens. Object screen the distance between object and screen is capital. Where convex lens is placed at two different locations. So let this be the first position of the convex lens. So that this distance from the object to the lens, in the first case be u. U1, first case u. So this is the corresponding image distance in that case. So V in the first case, that be V. So it's pretty clear, V plus U is equal to D. V1 plus U1, which is V plus U, is equal to D. Now, this lens is transferred to another position, again without changing the object and the screen. Image is formed on the screen. That is possible only if the object distance in the first case becomes the image distance, and image distance in the first case becomes object distance. 1 by f equal to 1 by b minus 1 by b u. Applying sign conventions will be 1 by b plus 1 by u. Here u is the object distance, v is the image distance. Without changing the lens, same focal length, without changing the total distance, you can have this to be 1 by u plus 1 by v. That means the object distance and image distance can be interchanged to satisfy the same thing. First case, what is u and what is v? Second case, the lens is placed in such a way, the lens can be placed in such a way, the image distance from lens to the screen is supposed to be the object distance, and the object distance from object to the lens will be the image distance. So this distance, which is the object distance in the case 2, that will be the image distance in the first, and this is the image distance in the second case. That will be same as the object distance in the first case. The question say the lens locations are separated by a distance d. That means this distance is the two positions of the lens. It's not two lenses, one lens shifted from one position to another position at a different time. Now, this distance is v, this distance is u, so d will be equal to v minus u. This is the key point of this. V plus u will be equal to capital D, v minus u is equal to small d. This is possible only when the object distance get interchanged with the image distance in the second case. Now we can write v plus u is equal to capital D, case number A, v minus u equal to small d, case number B. If you add both, d plus d equal to 2v, the u get cancelled. Same way, if you subtract this, v get cancelled, u minus minus u, 2u equal to d minus 2. From that, we can find v and u. v will be d plus d by 2, u will be d minus d by 2. Now, lens formula without sign convention. Once you apply the sign convention, u will be negative, v will be positive, f is already positive for a convex lens. 1 by f equal to 1 by v plus 1 by u with sign conventions. Now substitute the u and v values in that. So v is d plus d by 2, so 1 by v will be 2 by d plus d, plus 1 by u will be 2 by d minus d, taking LCM. 2 into d minus d plus 2 into d plus d by d plus d into d minus d. So 2d minus 2d plus 2d plus 2 small d, a plus b into a minus b is a square minus b square. The small 2d get cancelled, capital 2d become 4d. So 4d upon d square minus d square. If we cross multiply and solve it, become f equal to d square minus d square. That's a required expression. The important key point is, without changing the object and screen, a convex lens can form clear image only when the u in the first case becomes v in the second case, and v in the first case becomes u in the second case. That's a key point.